Good morning, everyone. Myself Rahul Rajeev, currently doing BE in Electronics and Communication Engineering, Sri Venkateswara College, Bangalore. When powering a circuit, you need a stable power supply. Then the popularity of USB 5 volt has become pretty standard. But what if you need 12 volts or 3.3 volts? Then you can use a voltage regulator. These devices take a voltage on one side and output a different voltage on the other side. In this, we are going to talk about linear voltage regulators. There are two types of voltage regulators, linear and switching voltage regulators. Linear regulators only need a small amount of components which are simple to add to the board but are not very efficient. Switching regulators can be made to be very efficient for a particular circuit but can be difficult to design. Here is an LM7805. This regulator may be the most important integrated circuit in the history of electronics, which is most popular because they are super easy to put into a breadboard and can dissipate lots of heat. Let's talk about how linear voltage regulator work. Looking at the LM7805, you can see pretty simple. A voltage goes on one side and a smaller voltage comes out the other. These are called decoupling capacitors. This thing is the source which provides the input voltage. It could be a battery, or the regulator, or even USB. The output is connected to a load. Load is a device like an LED, microprocessor, or sensor. For a linear voltage regulator, input voltage must always be more than the output. The input voltage needs to be 2 volts greater than the output. If the input is too low, the regulator will be unstable. Based on the connection of load, there are mainly two types of regulators: series voltage regulator and shunt voltage regulator. Series voltage regulator, a variable element or active path element such as a transistor, is connected in series with a connected load. The output voltage is measured through voltage divider between R1 and R2. This voltage is compared to reference voltage V reference. Shunt voltage regulator, regulating element or active path element such as a transistor, is connected in parallel with a connected load. The shunt voltage regulator is slightly less efficient, but it has a simpler implementation. Now let's discuss about the advantages of linear voltage regulator. It is very simple to implement, easy to use. It gives low output ripple voltage. It has a fast response time to load, less noise and low electronic magnet, cost efficient. Now comes the disadvantages. Efficiency of it is relatively low. It gives the output voltage less than the input voltage. That is, it performs only step-down operation. It requires a heat sink since it dissipates excess power as heat and becomes extremely hot during regulation. It requires large spaces. Now we go through the protection methods. Constant current limiting or fallback. The second one is the thermal shutdown. Third one, safe operating area protection. And the fourth one is the external protection, which can be used as like a crowbar. Next, we go through the applications. One of the most common example is the mobile charger. The adapter is supplied with an AC signal. However, the output voltage signal is a regulated DC signal. Every power supply in the world uses a voltage regulator to provide the desired output voltage. Computers, televisions, laptops, and all sorts of devices. Finally, thanking you for your time and cooperation.